This is 5.4 day 3, converting to vertex form using completing the square. There is an application problem, a word problem, that will be done in this lesson, but I'm going to save that for what we do in class together. There are two examples that we're going to do in this lesson. They're very similar, so if you want to watch one and then write one, that is fine. So if you think back to 5.4 day 2, where we focused on completing the square so we can solve for x and we get 2x values, this is very similar, but we're not going to move this c term over to the opposite side. We're going to keep it as it is, so it's going to change a little bit with completing the square. So go ahead and write this problem down. We have a function. It's a quadratic equation. We want to rewrite it into vertex form. So how you do this is you group the first two terms together, your ax squared and your bx. And I'm just going to leave the negative 13 off on its own at the end. Now we're going to complete the square. We're going to take half of 10, which is 5. So this should look familiar like when we were solving completing the square. Then we're going to square it. So we get 25. So we're going to add 25 right there. Well, remember when we had to add 25 to both sides to balance it out? Well, now we kind of have to do the opposite, or we have to subtract 25 over here to balance it out, because we just added 25 to this equation. So to undo it, we would subtract 25. So really it wouldn't be there. It's not changing our equation. Now we can go ahead and factor this trinomial in the parentheses. So when we factor this trinomial, we use the t-chart. We say, what are the factors of 25 that add to 10? Well, that's 5 times 5. Or remember when we were doing completing the square, the t-chart is always whatever your half is, which is 5. So when we factor this, we get x plus 5 and x plus 5. If we FOIL that out, we get back to this original quadratic equation. Now I'm just going to go ahead and combine like terms on the other side of my parentheses. So negative 13 minus 25 is negative 38. Now I have my function. I'm going to just go ahead and combine those parentheses together so that now it's in truly vertex form. So those two parentheses become one parentheses and then all squared. We have now converted this to vertex form. If you remember vertex form was, I'll just write it off to the side, f of x equals a x plus or minus h squared plus or minus k, where we always took the opposite, h, and then the same, k, because the inside of the parabola tells me how much do I move right or left. The outside of the parabola tells me how much I move up and down. So we're going to take opposite this, and then the same of that. And that is our h and k. So our vertex is negative 5, negative 38. That's my critical point for my parabola. Let's do another one. If you seem to understand that problem, then maybe you just want to watch this one. If that was a little bit difficult for you, then probably write this one down too. So again, we have another quadratic equation, and we want to convert it to vertex form so we can identify that vertex. So when you start off is you group the x squared and the x term together, and that constant goes outside the parentheses. I'm going to leave a little space, and then it's plus 145. Now I start completing the square. I take half of 24, that middle term, which is 12. Then I square it. 12 squared is 144. So that is what I'm going to add inside the parentheses, plus 144. Outside the parentheses, I have to subtract it to balance it out. Now we're set to factor this trinomial. What are the factors of 144? So what two multipliers of 144 add to 24? Again, it's whatever you're taking to get the half of. So 12 times 12 is 144. When I add 12 plus 12, I get 24. So we have x plus 12 times x plus 12. And then over on the right, 145 minus 144 is a plus 1. Now I'm just going to group those two parentheses together as x plus 12 all squared plus 1. Now it's in vertex form. It does ask us in the problem again to identify the vertex. So the vertex is always opposite inside the parentheses. You have to think opposite. So it's going to be negative 12. And then the same positive 1. So that's moving the vertex left 12 and then up 1. So there's my vertex, negative 12, 1. The next problem we're going to save for tomorrow in class. It's a word problem on page 347, number 61. If you'd like to look through it, you can. We'll cover it tomorrow in class. Here is your homework for what we're going to do in class. Up through these problems is what I covered in this lesson. So if you wanted to work ahead, you could. These couple over here are the word problems. I'd probably save those ones. This is about an 8-minute video.